Hello everyone. Today we are going to discuss the electronics subject of computer science, right? So basically, first of all, let us know what is electronics. Electronics is the field in which we are going to develop the circuits for various machineries or various like computers, etc. So as per this perspective, electronics is divided into two parts: analog electronics and digital electronics. So main area of electronics, analog electronics, is related to the electrical engineering, right, in which we are developing the circuits of electrical instruments like fan, AC or washing machine or something else. That part is related to analog electronics, and digital electronics is related to the computer fields, right, in which we are considering the electronics portion that is related to the development of the computer system or computer hardware, right. So first of all, let us understand the difference between the digital and analog electronics. See, in analog electronics, the sine waves are generated that vary its values continuously. See, in this portion, some of the values are positive and some of the values are negative below the zero line, right. So in this manner, the positive or negative, like in this manner, the values vary. Like here, for example, the positive 0.1 volt, here 0.2, here up to so on, and in this minus negative volt like 0.01 and up to so on, 0.02 and up to so on. These are the voltages in analog electronics. See, first of all, if we are talking about the development of the system or development of the circuits, like first of all, the analog circuits were developed, like the calculators, analog engine were developed. But if we are considering the digital electronics basically developed to reduce the deficiencies of analog electronics. See, in analog electronics, there was one major problem, like it gives us the approximate result. It doesn't give us the appropriate result, right? So if digital system always gives us the output in this form: either 0, either 1, either 0, either 1. Basically, this concept helps us to find the appropriate result for a particular problem, right? So these sort of systems are developed with the digital logic of our electronics, right? So why 0, 1, 0, 1, 0, 1 form is there? Why on-off form is there used in digital electronics? Because computer is made up of many different switches, and any switch can have only two states, either on state or off state, where on represent 1 and off represent 0 state, right? So in this perspective, the digital electronics gives us the result in 0 and 1. All the digital electronics related to the circuits related to computer, right? So these sort of logics we are going to develop, and we are going to solve the problems of digital electronics by using different methods. So before moving the development of digital electronics, like developing the circuits of digital electronics, first of all, let us understand some of the major concepts of digital electronics. The first concept that is used is number system. What is a number system? A number system is basically a system that helps us to identify what are the valid numbers in a particular number system. Let us suppose if we are talking about a decimal number system that we are familiar with, right? So in a decimal number system, there are valid numbers between 0 to 9, right? So starting from 0, all the rest of the digit till 9 are the valid numbers. So prior to this decimal number system, there were two number systems, like first non-positional, and second one is positional number system. Prior to this decimal number system, non-positional number system were used, because decimal number system is the category of positional number system. What are the non-positional number system? Have you heard about that Roman number system? What are the Roman number system like? We can say that we write 1 as I, then 2 as this one, 10 as X, or 9 as IX. So these sort of number systems or some Morse code like this codes were used for coding purpose. But the major disadvantage of these non-positional number system were like these number system doesn't have the concept of zero. If in any Roman number system we write any number that includes 0 with X or IX, like 20 is represented by XX, we are not writing any digit that includes 0, that represent 0. So to remove this disadvantage, we move to the positional number system. Why this is called positional number system? Because the number have weightage as per the position. For example, if I am going to write a number that is 239, it is a valid decimal number because 0 to 9 numbers are valid numbers in this. So why it is a positional number system? Because every number have weightage as per its position. Because see, it's a 1 place, it's a tens place, it's a 100 place. If I will write 2 as here, so it will not be considered as a 200. Like if I will remove it as here, it will be only considered as 2. If I will shift this 2 towards this one, right? So it will be on tens place. That's why it will be considered as 29. The number, every number will have the weightage as per the position. That's why it is called a positional number system. Like for example, if I will write as 3, 2, 4, right? So 3, it will be considered as 300, it's on hundreds place. 20, it's on tens place. 4, it's on ones place, right? So how you will write its position as this is on 10 power 0th position, this is on 10 power 1st position, and this is on 10th power 2 position. So you just calculate that 3 is 10 power 2 position, that is hundreds position, right? So plus 2 is 10 power 1 position, tens place, plus 4 is 10 power 0 position, that is 1, because anything raised to power 0 is 1, right? So it's called as 324. So it's called it as 324, 324, right? So in this manner, these number systems are called positional number systems, right? So this was the decimal number system. The decimal number system is the very basic number system that we have studied so far, like from our basic classes, right? So now what are the other system we are going to understand in this lecture? That is, our next number system is binary number system. Binary number system is only having 2 numbers valid, that is starting from 0 and 1. 2 number valid, that means always you need to start 0. If you want to develop a number system in further like coding, you want to develop some sort of number system, positional number system specifically, so you need to write it from 0 always, right? If 10, see in this decimal number system, total 10 numbers are there starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers are there, right? So overall 10 valid digits are there, so its base or radix is 10. And in this binary number system, only 2 numbers are valid, so its base or radix is 2, right? So this is the radix of binary number system. I have already discussed you that why binary number system is used in computer, because computer is made up of different switches and every switch can have only 2 states, either 0 or 1 state, right? So next number system is ternary number system, right? So the ternary number system, as the name suggests, it includes the 3 valid numbers as 0, 1 and 2, starting from 0, 1 and 2, and its radix or base will be 3, right? As if quaternary number system are also there. Quaternary 0, 1, 2, 3, so its radix is 4. So these are the number systems that we can use anywhere, like some of the special purpose systems can include these sort of the number systems, right? So similarly, quinternary, these sort of number system like quinternary, 0, 1, 2, 3, 4, radixes 5, including 0 radixes 5, right? So for example, the next other number system that like septenary for 7, and the most popular number system that we are going to now further discuss is octal number system. In octal number system, the valid numbers are from 0 to 7. So what will be the base? Its radix is 8. Right, because the total 8 digits are valid, total 8 numbers are valid. So after that there is a number system, hexadecimal number system. That is, hexadecimal number system is, in this valid numbers are from 0 to 9 and A till F. These are the valid number system. So the total numbers are 16. So its radix is 16. In this case, so why A to F? A represent 10, B represent 11, C represent 12, D represent 13, E represent 14, and F represent 15. So these are the total valid number systems, right? So moreover, if we have some other terminology for the number system, so we can just need to start all those number systems in from 0 to 9. And the most popular number systems we are going to discuss in our lecture is decimal, binary, octal and hexa. Although we will discuss some other number system, because if somebody can ask you the conversion from any number system to any other number system, so we need to develop the right algorithm that will be able to solve the conversion problem from a single number system to the other number system, right? So I will, in further lecture, I will definitely explain you in which situation you people are going to use all of these number systems, right? Because you may heard about like decimal number system, binary, hexadecimal and octal number systems. So in these number systems we will get to know that why we are going to use these number systems and in what situation, and what are the methods to convert that number systems to other number systems. So that's all for this lecture. So see you in next lecture.